Well, you've learned about multiplying polynomials in general. You've learned about the FOIL method for multiplying binomials together. And section 4.5 talks about special products. And we're going to just explore two types of products that I would like for them to be easily recognizable to you so that you can say, oh, that's this type of product, and we'll get it in just one step because we know what it is. As I mentioned in the section 4.4 tutorial, even though I have a one-step method for you, you're not required to use one step. You can go back to the beginning and just do all the distribution and finding and identifying like terms and combining them, etc., etc. But just to increase your experience, increase your power, if you will, of these products, I'm going to introduce these one-step methods. The first thing that we're going to look at today in this session is on page 1, so it's page 4.5-1, and an idea called the conjugate. The idea that I'm presenting here about conjugates will also be important in chapter 5. So let's try to learn this well. Actually, when I say the conjugate, it's probably not the best way to approach it because conjugates come in pairs. Conjugates come in pairs. Pairs of binomials. And they look almost exactly the same. But there's one thing that's different, and that is the sign between the terms in a binomial. For example, just some quick examples. Well, I can take example 1 here on this page. We're given one binomial is x plus 6. Its conjugate is x minus 6. That's all there is to it. You know, basically, same terms, x and 6. One is positive 6, one is negative 6. First terms are exactly the same. These are called conjugates, and we'll see what's special about them in just a little bit. Here's part B, y minus 5. The conjugate is, that's right, y plus 5. And part C, 2w plus 3. Simply put, the conjugate is, that's right, 2w minus 3. 2w minus 3. Conjugate for D, you have 4c minus 1 and its conjugate. It's getting pretty simple now, isn't it? 4c plus 1. And even if the first term is squared, like x squared plus 8, the conjugate is, yep, x squared minus 8. Really simple. That's the idea of conjugates. Now, what is most interesting about conjugates is not what they are, but what happens when you multiply them together. In fact, I can take these examples real quickly, and if I made all of these multiplications, usually they'd be much closer together, but if I made all of them multiplications, and we used either the FOIL method or maybe that one-step method I taught you at the end of section 4.4, we would get the, in fact, let me write it this way. Here's first. Remember outer plus inner? We had talked about that. And then lasts. If we did that here on the first one, the first is x times x. That's x squared. Get this for the outer and the inner. I'll write it down here. The outer is negative 6x, and the inner is positive 6x. Exact opposites. The lasts, positive 6 times negative 6, negative 36. What's special about this? Outer plus inner becomes 0. So for this particular example, we get simply x squared minus 36. And again, it's because the second terms, positive 6 here, negative 6 here, are opposites. So when we find that outer product and that inner product, we'll be getting opposites. And they will always add, when we talk about outer plus inner, they'll always add to 0. And we get just two terms in the end. We'll do letter C here the same way. The firsts, 2w times 2w, 4w squared. Put a little equal sign there. 4w squared. Outer is going to be negative 6w. See that? Negative 6w. Inner will be positive 6w. Positive 6w, negative 6w. They add to 0 again. And then the last is negative 9. Whoops, excuse me. Negative 9. So that becomes 4w squared minus 9. Let's do letter D. Same way. The firsts, that means 4c times 4c, 16c squared. Outer. 4c times 1 is a positive 4c. Negative 1 times 4c is a negative 4c. Think about it. Positive 4c and negative 4c. Positive 4 and negative 4 add to 0 again. And this is true every time you multiply conjugates. Of course, don't stop there. We got still the last to do. Negative 1 times 1 is a minus 1. In this last one here, the same idea is going to happen, but x squared times x squared, the firsts. X squared times x squared. I'm going to just draw off to the side here. X squared times x squared. That's x to the 2 plus 2. You know how that product rule of exponents, that's x to the 4. Okay, so this becomes x to the 4th, but again, outer and inner products. Outer, negative 8x squared. Inner, positive 8x squared. Negative, positive, of the same thing, they're exact opposites, they add to 0. Even when it's x squared, they still add to 0. When we multiply to get the lasts, that's 8 times negative 8, that's negative 64 minus 64. Okay? So I have, in a sense, done example 2 as well, but I just didn't use the numbers in example 2. Did the idea of example 2. So if you go ahead and read through example 2, you'll see how this is done. And actually, example 2 is mostly like this one, where I showed all the steps. And example 3 is kind of like these, where I just get right to the answer. But I'm going to do example 3 anyway and introduce the rule that's there, where it's just a one-step process. Whenever we're multiplying conjugates, if they're not exact conjugates, this won't work. But if they are exact conjugates, where the first terms are exactly the same, and the second terms are simply opposites of each other. If they're conjugates, then what I'm about to present to you will always be true. And I'm looking now on page 4.5-3. So let me write that out there as page 4.5-3. And it's what we're going to call the difference of squares. And this is explained here in the textbook, so I want you to do the reading. The rule says this. If we multiply two conjugates together, and I'm just going to use a plus b and a minus b, and then we'll provide some examples, that we will always get a squared minus b squared, meaning this. As long as they're conjugates, and these are because the a's are exactly the same and the b's are opposites, that if we use the FOIL method and got all those four terms, the middle two terms would become 0. And we wouldn't need to see them at all. And it has the effect of multiplying just a times a, well, that's a squared, minus b times b, that's b squared. Why minus? Will it always be minus? Yes, it will. And the reason it's always going to be minus right there between them is because, remember, these are opposites. That means one positive, one negative. And when you multiply opposites, when you multiply a positive number times a negative number, the result is always negative. In squaring the b, we make sure that we have negative first here, and then we just square that number. Let me show you here example 3. A. So we have x plus 3x minus 3. I mean, if we went the long route here and we did, the whole FOIL method, we'd get the x squared and a negative 3x and a positive 3x for the inner, and the last would be negative 9. But again, these two right here become 0, so we would end up simply with x squared minus 9. If, though, we use this difference of squares rule right here, really, and multiply, we're going to get the first one squared, which would be x squared, minus, it'll always be minus, and then the 3 squared, which is 9. By the way, I wanted to make sure I pointed this out. Difference. Difference means, well, yeah, they're different, but in math, what does difference mean? What does it mean? It means subtraction, that's right. So difference, subtraction, of squares, Notice the effect of multiplying conjugates is that we actually get the first term value squared and then the second one squared, still subtracting them. So difference of squares, and that's why it's called that way. Oh, by the way, no, let me just continue here with the next example. Here's example B from 3B. 4x minus 7, 4x plus 7. Now, what I wanted to point out here is, notice that this time the minus sign is written first and then the plus sign. Whereas up here we had the plus sign and the minus sign. Does that matter? You're right, it doesn't matter. These are conjugates up here, these are conjugates down here, and they will multiply to become the difference of squares. Now, if we understand this, then what we understand is that we'll have one term minus another, and those two terms will be found from, first of all, multiplying the 4x times the 4x, or squaring the 4x. Well, 4x times 4x is 16x squared. And then 0, we'll get the, whatever we get there. Well, in this case, it's a positive 28x and a negative 28x, but don't want to go there. Negative 7 times positive 7 is negative 49. So this becomes 16x squared minus 49 in one step. And part C says we have, oh man, x cubed minus 5y. X cubed minus 5y times x cubed plus, 5y. Better get that right there. Plus 5y. And it's going to be the first thing squared. Now, we could look at it this way. It'll be the first thing squared minus the second thing, term. Should use my correct mathematical words here. But the first term squared means x cubed being squared. Minus. And the reason it's subtraction is because of these being conjugates. Those are opposites. So a negative times a positive is negative. But beyond that part of it, this second term is 5y. So it'll be x cubed squared minus 5y squared. We can't leave it like that. We really shouldn't. We should continue on. And this first one becomes x to the 6th minus 25y squared. Now, just as a brief reminder that x cubed squared is what I had over there. And that's the same thing, by the way, as x cubed times itself. And that means that we can add the exponents, 3 plus 3. That becomes x to the 6th. You might also remember the rule that says if we have a power to a power, that we actually multiply those exponents. And so that's another reason why it's x to the 6th. So that's what we have down here, x to the 6th minus 25y squared. Okay? And so I'll let you read the rest of that. I'm going to move ahead now in section 4.5 to page 5, where we have another special multiplication process.